In the last section, we talked about functions and formulas. So it's not a stretch to talk about geometric measurements because that is so full of formulas. Now, we're going to talk about perimeters, areas, and volumes. There's a missing Oxford comma right there that I wish I had not overseen. But we're also going to talk about the units too, because that is so important in this class, and I preached it before and I'm just going to continue preaching it. We are going to keep track of the units like a hawk. All right, example 1, find the area of this rectangle shown. Okay, this is a great image from your textbook that I put in here. So let's see, the area. So now we have to remember that the area is how much it covers, everything inside. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There are 20 squares. So the area here is 20 square inches. That's how much area it covers. And a ton of my students immediately go straight to the formula. So I always go to the intuition first. How many? Well, there are 20 square areas that this covers, or this area covers 20 square inches. But a lot of my students say, okay, well, this is a 4 by 5. And so they will immediately write this, which is fine. I would say that's good, not great. If I were going to have a little bit of a fix on this, I would say this, you really meant this is 4 inches by 5 inches. The dimensions of this are a 4 inch by 5 inch area. So 4 inches by 5 inches to make 20, and inches times inches will give us square inches. Okay, so a lot of people look at a formula. They use the formula length by width. They put in the numbers, they get an answer, and they're like, I'm done. But the answer to the question, find the area of the rectangle shown, is this. It's 20 square inches. This rectangle covers 20 square inches. And so without these units, it's really weird to think about what's the area? The area is 20. What does that even mean? So I'm really picky when it comes to units now. Is that 20 what? Is it 20 inches? No, it's not 20 inches, because when I think about that, I'm thinking, okay, that's a length of one distance. It's 20 squares. The area is 20, it covers 20 square inches. So that we really are thinking about these squares. Yeah? Okay, find the volume of the rectangular prison shown. All right, volume is counting up cubes. Let's see. In this first layer, and so here's what I mean. I'm really talking about this front layer right here. Okay, I'm gonna just kind of highlight. I see that there's a front layer and I see that there's a back layer that is assumed to be the same. So I see this is a 3 by 4. There are 12 cubes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12 cubes in the front, 12 cubes in the back, making a grand total of 24 cubic inches, or 24 cubes. So the volume is 24 cubic inches, and the formula used here, length by width by height. Okay, so a good, not great answer would be, okay, this is a length of 4. The rectangle had a length of oopsie, 4. The rectangular prism has a width of 2. And this rectangular prism has a height of 1, 2, 3. It's 3 tall. And of course, 4 times 2 is 8. 8 times 3 is 24. Okay, so I look at this and I'm like, thank you for knowing the formula. That's wonderful. But I really want this written in terms of a good answer to this problem. Find the volume of the rectangular prism shown. 24 cubic inches is much more, descriptive. It's all about the adjectives. There are 24 what? 24 cubes. And how big are those cubes? Well, they're an inch by an inch by an inch. So there are 24 cubic inches. So if you're going to use the formula, 4 inches by 2 inches by 3 inches, and notice how all of those labels match, so that we could write that this is 24 cubic inches. Yeah? Okay. Do we measure the perimeter of the rectangle or the rectangular prism? Okay, so if I look at the rectangle versus the prism, the 2D image versus the 3D image, which one do we compute perimeters for? Well, that depends on you remembering that perimeter means distance around. So this perimeter we actually compute for the 2D image because the distance all the way around on the outside, or if we go along the perimeter of it, along the outside of it, we can do that for a 2D, but it's very awkward to say, well, what do you mean? How are we walking around this three-dimensional thing? So, perimeter is for the rectangle, the 2D image. Do we measure the surface area of the rectangle or rectangular prism? Well, now it has a surface. So immediately I'm thinking, well, 3D images have surfaces. A 2D image is just one surface. So if you're just talking about this, if you're specifying that it has a surface area, these 3D images have several surfaces, and we would find all of those to find the surface area. So this one, rectangular prism. A painting. I'm going to reference your book. So there's the painting he puts in here. He says, my friend, yep, I'm going to botch this like every white woman would. David Nahar made this painting. And when he says, my friend, Sebeki is referencing that. So, but I think it's valid for any painting. So a painting has dimensions 24 by 32. Find its perimeter, its area, and its volume. Okay, I'm going to shut my binder. There we go. That way I don't lose that page. Include your units. Perimeter. So I actually need to draw this. There's my painting. And if I were going to draw this tree, it would look like this. There. There's my replica of that painting. It is 24 inches by 32 inches. Just 1 minute, please. Okay, this is my kiddos knocking at the door. Perimeter. The perimeter is the distance along the outside. So the outside of this, or the perimeter, is 24 inches, 24 inches, 32 inches, plus an additional 32 inches. Or, if you prefer the formula, 2 L's and 2 widths. 2 lengths, 2 widths, and you compute this. I already did this on my calculator just to save time. It is 112 inches all the way around it. Area. Area is, so instead of drawing the grid now and counting, I mean, that's a grid of 32 by 24. That's a lot of little squares. So I'm going to use the formula. The length 32 inches by the width of 24 inches. 32 by 24 is 768. Yeah, I definitely didn't want to draw 768 little squares. Square inches. And don't forget that inch times inch is inches squared, or square inches. Yep. Okay. What units do we use to measure perimeter, area, and volume? Okay, so in this last one, we were sure to tell. Perimeter is measured in length. In particular, what we just saw was just plain old inches. The area is measured in squares. In the example we just did, square inches. The volume was measured in cubes. And in the example we just looked at, cubic inches. Okay, perimeter. So let's write these down before moving on to the next example. Perimeter is the distance around the outside. And I'm going to specify of a 2D shape. Area. Okay. The area to me is the measurement covered on the inside of a 2D shape. So the coverage maybe of the interior, whatever, of coverage of the interior, okay, within a 2D shape. Squares. How much coverage is that thing? Oh, you know, it's like 36 square inches. And volume. Volume isn't the distance around or the coverage in the interior of a 2D shape, but it is the amount that is able to be inside within a 3D object, I'm going to call it. So, amount contained inside or within. Very popular. Within a 3D object. Okay, so perimeter, distance around the outside of a 2D shape. Area, coverage of the interior within a 2D shape. And volume, amount that can be contained within a 3D object. This page right here with conversions is really just for your convenience. I keep it throughout the entire semester so that if you're ever asked, instead of inches, I want it in feet. Instead of cups, I want pints. It's just for your convenience, okay? So if you're given something in centimeters and it wants it in inches, or you have something in inches and it wants it in centimeters, this is really just to have conversions right at the tip of your hand. In the next video, we're going to recall several formulas. We've already recalled a few of them, but let's just recall a bunch of them so that we have them in one spot to reference. And I just got a voicemail.